Hi everyone, this is the last QGIS Hydro module, number 5, creating SCS curve number grid. The objective of this module is to learn how to generate a raster dataset of SCS curve number for any watershed by using land use or land cover and soil data in QGIS. The SCS curve number method is used in many hydrologic models for computing excess rainfall. Having a curve number grid gives you the utility of extracting curve number for any area in the watershed without performing needed calculations. Successful completion of the module should enable the QGIS user to operate raster data using QGIS processing toolbox and reclassify raster and perform mathematical operations on raster using the GDAL raster calculator. And lastly, create a map of SSCN by using land use and soil raster with the CN lookup table. The main data needed for this module are provided on my GitHub repository. You can directly access it with this address. So if you will go to this address, then you can find my GitHub repository. On here, you need to find the Hydro Modules folder. Click. After that, you can also find this 05 creating SCS curve number grid folder. On that, you can download this QGIS 05 data zip file with this button to download. So after downloaded and unzipped the zip file, you can find these 4 different data. So 2 text files and 2 TIF image file. One would be the soil data and the other one would be land use data. So I will give the details of these data with my tutorials for the QGIS platform. So basically you need these 4 different data with 2 text files and 2 image files, soil and land use. Okay? So after opening this new map canvas in the QGIS platform, as usual we need to save this project with save as. So I will save this QGIS Hydro 05 folder with the QGIS 05 and extension would be .qgs. Okay, so after that save this the QGIS 05. Okay, after that you need to open the data with this open data source manager. So click this icon and then you can bring this new window for the data loading. So I will bring the raster data with this browse button. So in that data folder, as I told you, we have 2 different text files and 2 different TIF files. So I will firstly open this land use TIF. This is the Yongdam Dam area in South Korea. So if you click to add, then you can find this newly added the land use map. This is one of the dam watershed in the South Korea. So I will use this data for creating the SCS curve number method for this dam watershed area. So in here you can find just gray colors for that. So we will change this map symbology. Before that, if you right click and to see the properties, you can firstly check the information. So on here you can find the CRS. So as usual from the previous videos, I will use this data is already projected with Korea 2000. This is typical projection for the Korean watershed. So I will use this kind of CRS. Actually, this is already projected with the 30-meter resolution for the prepared data. So you can find this pixel size with 30 meters. Okay, so this is already prepared data. Okay, so after that I will change the symbology for that. So now it is just a single band gray color, so I will change with this paletted unique values. So after check this menu combo box, this selection, after that just use this default random colors. Okay, after that press this classify button, and then you can see these the default colors for different 22 items, 22 different land uses for that. So if you click the apply button and OK, then you can see this the color map for the land use for the Yongdam watershed. So if you expand this one, you can also see the colors for that. So in here, we should check these number means. Actually, this would be one of the land use classification in South Korea. We need that kind of classification information for this 22 classification for the land use. So if you see this prepared table, you can see these 22 different categories for the land use. Actually, in South Korea, we used this kind of the classification from the Ministry of Environment. So I just bring this kind of data for the land use. So you can find many different classifications. Actually, with this 22 different categories, I will revise this kind of classification with 4 different items. So I will use water and urban area and forest and agricultural things. So already I grouped this kind of the already the given the emis classification. So you can see with these the different numbers with the different descriptions for this water, urban, forest, and agricultural classification. So I will reclassify from these 22 different categories from the original Ministry of Environment classification to this reclassification with 4 different the water, urban, forest, and agricultural things. For that, I will bring the class table text file. So this is provided for the data file. Okay, so in this data file, text file, you can see the minimum, maximum, and values for that. So actually, this is range for these 4 different classifications. So for example, this line means for this kind of things. Actually, I would like to use reclassify the numbers for the land use as a 1. So for this 1 classification, we need to change it from these numbers with these different descriptions. So I just use the minimum and maximum numbers for this new classification for the number 1. So in here you can find this minimum and maximum. So I just create these 2 rows for the 1 classification. How about this 4 classification, number 4 classification? So you can see 3 different groups. So from 7 to 11, this is just the minimum and maximum. And also 15 to 17. So this is another one. The last one would be 20 to 21. So this table represents this kind of the classified tables. Okay. So I will use this class table text file. Okay, so go back to QGIS platform And after that, I will bring the text file that I mentioned right before with this data source manager. So on here you can find this delimited text menu, and then you can select with this browse button this class table text file. So double click. After that, you need to change this file format with the CSV and the geometry definition with no geometry. Actually, that kind of text file has no geometry. So we need to select these two items. After that, just click Add. And then you can see this added class table. So now I will make processing job for the class py. So for that, I will use this processing toolbox. So on here, you can find many the toolbox on here. So how about expand this last analysis? And then you can find this classify by layer. So double click for this classify by layer. So you can see the new window for that. After that, you need to select the parameters. So firstly, you need to select the last layer with this land use data with YD land use. 용담댐 land use data we just loaded on this the map canvas, and then check the band 1 and this layer containing class breaks. So that would be this class table file. So after that, you need to check this minimum, maximum, and output value field. So minimum would be okay, but you need to change this as a maximum value. After that, the last one would be the value. So and then I need to check the advanced parameters for that. So on here you can see the range boundaries. So I need to check this one. This is I need to select this all including these equal values for that. After that, the data type would be the integer. So I checked this int 16 things. Okay, so collapse this advanced parameters for that. After that, I will save this file, this the processed file with the name of yd land use lu and reclassify. So reclass. So I will save this file with the TIF image file. So click save and then click run for this the classification. So after that, you can find this the already created the job for the reclassify. So on here, this is again for the gray map. So if you change with this right click and property and go to symbology and again the paletted unique values and then reclassify. So you can change all these the colors again. So this one value would be the water. So I will make blue color for that. Okay, and second one would be urban. So I will use this pink color for the urban, and the number 3 would be the forest. So I will use this green one. And then number 4 would be the agricultural land. So I will use more yellow things for that. So click OK. So I will use this the unique values for this the newly created the newly reclassified the land use things. So apply and click OK. So and then you can see the reclassified land use. On here you can clearly see the majority area just occupied with the forest, and then follows for the agricultural land, and then urban area, and you can see some the water zone for that. So if you expand this zoom in button, you can see this the classified, reclassified the land use data. So go back to this full extent, and then you can see this reclassified land use data. So based on this reclassified land use data, I will bring another layer, data layer for the soil. So I will click this Open Data Source Manager again, and then go to raster. You need to select this HSGs YD file. Double click and add. So again, this would be the gray map. So as usual, you need to change this symbology with the unique value. So classify and apply. Okay. Then you can see this 4 different classification for this soil data. Actually, this is already prepared data. So if you see the property and the information, this is again already the projected with the same projection with Korea 2000. And also pixel size would be 30 meter grid cell size. Actually, I bring this data from the already given the soil data. So actually I got this data from the global web sources. So in here you can find the original data sources for the global hydrologic soil groups. This would be the 250 meters data for each pixel. So from this data I got that the 30 meter based grid based the soil data. For the curve number method, this kind of hydrologic soil groups information is required. So in this video tutorial, I just used this already given hydrologic soil groups data. Okay, so go back to QGIS platform. Again, in this video tutorial, I just used this 4 different classification for different item based the land use data, and also I just used the 4 different hydrologic soil groups data. So with these two data, the curve number, the grid can be generated. So I will give the details of the lookup table for creating the curve numbers for this the already classified the area for the Yongdam Dam watershed as an example. So again, this two data for the land use and hydrologic soil group data is required for creating curve number grid data. So before creating curve number grid map, so I will show you the table for this kind of creating curve number grid. So in this table, you can find these 4 different land use the values with the descriptions. Water would be 1, urban 2, forestry, and agricultural 4 with this land use values. And also we have this soil with the hydrologic soil group A, B, C, D. This is kind of the new classification for this HSGs things. So we have already this A as a 1, B as a 2, and etc. So with these two different classification, we can assign the curve number values. Actually, these the curve number values from the obtained from the SCS 55 report. So for more details for the curve number things itself, you can report to this kind of reports for that. So all these curve number values we can assign with the QGIS processing things. Actually, I will use this GDAL-LAST calculator to give all this kind of computation for the last pixels, okay? So go back to this QGIS platform. Now I will use GDAL-LAST calculator. So you can click this toolbox on the processing tool. After that, you need to expand this GDAL. And then last miscellaneous toolbox, you can find this last calculator. So double click. So on this new window for the last calculator, you can firstly set the input layer 8. So for this one, I will select this already classified land use data. So this YDLU reclassify. So please check the number of layers for the band with 1. And another input layer B would be this YDS HSGs file. After that, click this band again. And then leave all the other layer things on here. After that, you need to insert this calculation with GDAL metric syntax using this one. So for this one, so if you open this CN query text file on the data folder, you can see all the syntax for this data query. So you can see the different numbers with the different A and B with the classification. So please select all these the text and copy. After that, paste on here on this box, and then you can also find this the syntax on here as well. So after that, you need to make some save things on here, save to file, and then you need to click to CN grid on here with the TIF file. So just save. So and then leave all the different parameters as a default. So this is important. First layer A would be land use, B would be soil with the hydrologic soil group. So after that, click Run to execute the calculations for the two different layers for creating the curve number grid. So after some seconds, you can find this succeeded message on this log box, and then just close this one. After that, you can find this the gray map as well. So after that, right click the properties, and then go to symbology tab with this unique value and classify. So on here, this would be, so if you apply and can see this one, you can see the curve numbers on different values. I will not suggest to use this symbology, but the random colors, you can also find the different colors map. So in this case, I will use this yellow and blue things for representing these curve numbers. So apply and OK. So in here, the color is changed for the curve number grid. So depending on this curve number values, the run-up characteristic would be different for the hydrologic modeling things. So for example, this 100 would be the water things. So that means this all contribute for the as a excess rainfall. I mean the runoff. But if the low values fall with this kind of the 30 things. This is not much contribute for the run-off things. So with this colors will represent the kind of run-off potential things with the curve numbers. So I have succeeded to obtain this curve number grid map from the land use and soil data. After that, I can represent this kind of runoff potential for this watershed. So I will provide the details for the curve number itself. You can easily find on the Google or hydrology textbook for the curve number theory itself. This is really useful and simple the method for getting the excess rainfall things that is contribute to rainfall for the runoff for the watershed. Okay. So in this QGIS Hydro Module 5 video tutorial, I have made demonstrations for creating SCS curve number grid using land use and soil data. Including this video, all the 7 QGIS Hydro modules have covered the basics of GIS work required for the hydrological modeling, including data handling with projections, as well as a watershed-based analysis for rainfall runoff applications. With these my video tutorials, I hope to help the QGIS users to learn hydrologic modeling works. Thank you for watching.